Lesson 10.5 is about special segment constructions. Okay, the first construction is construction number 12, to take a given segment, in this case AB, and we're going to divide it into any number of congruent parts. So let's start off, let's divide this AB into 3 congruent parts, so basically into thirds. So the first thing we do is we take a dummy line and form an angle up from A. And then we choose a convenient radius, and we mark off, if we put the compass tip on point A, choose a convenient radius, and mark off equal segments. Okay, 3 equal segments, because I'm going to divide AB into 3 congruent parts. Then I connect from point B to that point of intersection right there. And now what I want to do is I want to copy that angle 3 times. So I put my radius tip right here, I make an arc, and I put the radius tip right here and make the same arc, and I put the radius tip right here and make the same arc. Okay, now I take the tip of my compass and I measure, I put my radius tip here and measure across that angle. And I copy that 3 times, two more times. Now I go from these points through those points of intersection, and as you can see, we create parallel segments. But what we've done now is we have divided AB into 3 congruent segments. This one, and this one are all the same measure. Okay, construction number 13 is to construct proportional segments. So if I'm given 3 segments, A, B, and C, and A is to B as C is to some segment we need to create, X, we're going to learn how to construct segment X. Okay, so first I have the 3 segments drawn to the left, A, B, and C, and I want to create segment X such as the ratio of A's length to B's length is the same as the ratio of C's length to X's length, and we can see that X is going to be longer than C. So first we just draw a big angle, and we measure the length of segment A. So anyway, we measure segment A, and we put our compass tip on the vertex of the angle, and we copy segment A's length. And then we measure segment B, and we put segment B's length, segment B, right next to segment A. And then we measure the length of segment C, and we put segment C's length up here. Now, the next thing we want to do is connect from right here to right here. So we have, we've connected, we've made a little triangle with sides A and C. And then now we're going to copy that angle over to B. So I'm going to put my compass tip right here. I'm going to make a big arc here. And then I'm going to keep the radius the same, put my compass tip here, and make a big arc like so. Then I'm going to measure the span across this arc. And so I'm going to put my compass tip here and measure it, move my compass tip over here, and hit the same arc. Then the last thing to do is to connect from, okay, the last thing to do then is from point B, which I fixed, I'm going to go up through that point of intersection. So I've made 2 parallel blue segments there. And then this segment here will be X. And then it will be true that the ratio of A to B will be the same as the ratio of C to X. Or we could also say the ratio of A to C will be the same as the ratio of segment B to X. Okay, in our last construction, number 14, we want to construct the geometric mean of 2 segments. So I have 2 segments, A and B, and I want to construct segment X such that the length of X well, that A is to X as X is to B, that they're proportional. So the first thing I do is I copy the length of A. So I'm going to make a long segment here, take an endpoint, and copy A. And then I'm going to copy the length of B next to that. Okay, now what I want to do is I want to find the midpoint of that whole segment. So I will do a perpendicular bisector of the segment, the entire thing, and find the midpoint. And let's call that M. Okay, now what I want to do is I want to construct a circle with the radius from M out to each of these endpoints, and actually I just need a semicircle. It goes like so. Here. There's a better one. Okay. Now the last thing I want to do is go to the junction here between A and B to this point, and I want to go perpendicular through that point up to the top of the semicircle. So from this green point, I'm going to hit to the left and the right 2 anchors, and then I will, from those anchor points, swing up, and swing up, and connect through. And I'll dash it up there. It turns out that the length of the green segment where it intersects the top of the semicircle there is X. And that X is the geometric mean between the 2 segment lengths, A and B. So A is to X as X is to B. And that is it.